A politician claims that the mean salary for managers in his state is more than the national mean, $81,000. Assume that the population is normally distributed and the population standard deviation is $8,100. The salaries in dollars for a random sample of 30 managers in the state are listed. At alpha equals 0.1, is there enough evidence to support the claim? Use technology. Well, we're going to use StatCrunch, which, if you notice, there is a little button in my stat lab over to the right that says StatCrunch. And you're going to left click on that in just a moment to bring up the interface. But for right now, let's go ahead and talk about the hypotheses. There are going to be two hypotheses that we have to determine here. We're going to have the null hypothesis and we're going to have the alternative hypothesis. Remember that the null hypothesis is always a statement equality. It may contain a less than or a greater than symbol also, but it will always contain some symbol of equality in it. Now we need to go ahead and look at the information again. A politician claims that the mean salary for managers in his state is more than the national mean, $81,000. So that means that the population mean is going to be considered to be 81,000. And this politician states that it is more than the mean. So that means that our statement, our null statement, will be the fact that M, or mu, is going to be less than or equal to 81,000. And that the alternate will be that the mean is greater than 81,000. Notice that this is our claim here. And the null hypothesis is always the one that we are going to reject or fail to reject. So if we fail to, or if we reject the null hypothesis, we can go ahead and accept the alternative hypothesis or alternate hypothesis. So we'll go ahead and verify that we've done this correctly, and we have. The next statement is identify the standardized test statistic. Now, as I said, we're going to use StatCrunch, which is right here. If I left click that, that's going to open the StatCrunch window. And when we open the StatCrunch window, I'm going to go ahead and make this a little smaller so that it fits in the recording so that everybody can see what we're doing. It's blank, okay? There's nothing in there. Well, you'll notice there's a little blue window here. If I left click that, it gives me some options, and I will left click open in StatCrunch, and you'll notice now that the StatCrunch window actually has values in it. If you left click StatCrunch here or from within my stat lab, it's blank, you can go ahead and add your own data. But let's look at what we've got here. We know that we're going to use a z-test on this because we assume the population is normally distributed and the population standard deviation is 8,100. The salaries for a random sample of 30 managers in the state are listed. Okay, so this is a z-test because it's 30 or greater. So in StatCrunch, left click the stat button. That's going to give you a pop-up window. Scroll down and highlight Z-Stats. Do not click yet. Scroll over and highlight one sample, and then wherever the pop-up window comes up with, you want to left-click with data. We're going to left-click var1 here. Notice that it populates this field to the right. That's because the column that we're dealing with is called var1 or variable 1. Do not worry about the standard deviation. You can put that in there if you want, but StatCrunch will calculate it automatically. You do not need to worry about the where or the group by. We are going to perform a hypothesis test. So, what is the mean? Well, it is $81,000. So we type in 81,000. Notice that this has a statement of equality here, and in our original statements it was mu is less than or equal to 81,000. Well, it doesn't matter because we're going to go ahead and accomplish the same thing by going ahead and left clicking greater than on the alternate hypothesis. We now have our statement of equality in the null hypothesis, and you can assume in this particular case that when we type this in, it's going to be a less than or equal to. Okay? So you don't have to worry about there not being a less than sign. And now all we're going to do is left click compute, and that's going to give us this table. Now notice in the table that it gives me the sample mean, which means that's the mean of all these all the data in the sample. Gives me the standard error, gives me the z-stat, and it gives me the p-value. The z-stat is what they're asking for over here in part B, right here. Identify the standardized test statistic. Notice that it says round the final answer right here to 2 places as needed, round all intermediate values to 3 places as needed. So right here, the z-stat being 2.2939074 rounds to 2.29. And so that's what we're going to go ahead and type in right here, 2.29. And I will check my answer, and I'm told that I've done a good job. The next thing is find the p-value. Well, we'll need to bring back up my table because you'll notice that the p-value is the next value over from the z-stat, which is right here. Notice that we need to round to 3 decimal places as needed. So this is going to be 0.01, and that's going to be 1. So this is going to be 0.11. That's what we're going to type in right here in StatCrunch, or my stat lab. So 0.011. And we check that, and we've done nice work. Then the next part that we're going to look at is going to be decide whether to reject or fail to reject the null hypothesis. Well, since the p-value is at 0.011, it is definitely less than our alpha level. And so there is enough evidence to support the claim that the mean is greater than 81,000. So there is sufficient evidence to support the claim that manager's mean salary is more than the national mean. And that means that we will reject the null hypothesis, because if you remember, the null hypothesis was stated as being less than or equal to 81,000. So let's go ahead and reject the null hypothesis. And there we go.